right, cool. Let's get started. So starting from this hello world as always, but maybe more coming from the streaming side. But this is not really a new thing, right? Everyone kind of embrace this real time today. Like you order on the Uber side, you order a pizza, you want everything can give you updates in the real time. That's obvious. And besides that, all the instant message, all the gaming, video, everything is real time. I mean, if this is not real time, you think this is something is broken, right? So that's a very different expectation than what we have maybe 5 years ago, 10 years ago. And that's is more from the marketing research institution side, but we don't have to read into the detail, but the idea that is the potential of this real-time data is huge, right? For example, in this first number, about 30% of the new data will be real-time in next few years. And there's only 1% of the data is analyzed, and the rest is just hidden or unused in random file system, in Kafka, in some other system. So if you can have the right tool, the right process, and also making sure you have the right use case and scenario to make a good use of the real-time data, then you have much kind of more advantage to make your customer happy, to tracing with your competitors. And also go back to the more like use case or the reason why this is such a great time for us to work on the real time. Let me just compare what's in the past and what's happening right now. So for the customer demand or expectation side, yeah, I mean, for example, imagine, I'm not sure, I'm coming from China, so it's kind of different story, but in China, everything goes crazy. You order anything like before 11 a.m., you get a chance to get this shipped on the same day. And the people get a much higher expectation, but 5 or 10 years ago, it's common that it's ordered this week, you get next week, I guess maybe same. You are the local for Vancouver, so maybe is that kind of expectation 5 or 10 years ago?
That you order today and arrive next week?
Yeah.
I think that's the expectation mostly today as well. Right? Like today, if you get it the same day, that's very rare. Okay. Possible, but rare.
Yeah. Yeah, again, the people want to get things faster and but
it definitely is getting faster.
Yeah,
right?
yeah.
You can tell.
Yeah, exactly. And similarly, that is in the past, I guess when I visited the US 10 years ago, maybe I have to make a phone call to reserve, hey, can you send me to the airport tomorrow morning? But now you just pick up your phone and in a few minutes, you can get an Uber to keep up with you. And similarly, that is, you use a certain service and the bill can come quite late. I think, I'm not sure how many of you using EVO. I think when I first arrived Canada or Vancouver, 2000 maybe 17 or 18, when I write a EVO, I cannot see the bill immediately. I have to wait for the next day. They may be doing kind of like Hadoop or MapReduce stuff in the midnight to get generated bill. But today, or recently, that is once I finish, they still maybe in the next minute I can see how much I spent. Then that it's very different experience. People once the experience or the expectation getting higher, it's very difficult to get low. So the demand is high. In the past, we spent a lot of time on the email, on the Word document. Today, I forgot what's my last time writing a formal email. Everything is on the Slack, and we're using Google Doc a lot. So this cadence is different. And also in the past, people talking about ERP. Today, there's a lot of Web3, IoT, EV cars. So those generate a huge amount of real-time data, and the people want to understand what's going on, what kind of action they should take. And also from the technology side, things make this is much more achievable compared to maybe 5 years ago, 3 years ago even. Like even some of the traditional company today with some legacy stack, they still expect this T+1. That is, if I can run a report to understand what's going on, what was going on yesterday is good enough. For some of the decision making, it's their expectation. But with the new tool, we are having this buzzword like a modern data stack or modern streaming data stack. So people really embracing new tools to kind of doing, for example, A/B testing and doing more documentation even doing data quality or unit test for the data itself, and they want to get the data streamlined and have everything can work nicely, and you can get the result in the next few minutes, even next few seconds. So this is quite different than what we have in the past. This T+1 report. I understand correctly. It is not really big. Thank you. Streaming technology, might happen. This is a collective technology, right? All the microservices, Kubernetes, all the better database, everything together make this possible and raise the bar for customer having a high expectation to get real-time insight. But this is more like fat, right? So combining this factor together, people wondering why you cannot give me the report earlier, why I have to wait for so long. So the reason why we think this is the right time to work on streaming or work more on the streaming is mainly this two sides. One is the expectation is getting much higher, no matter as an end user or at the enterprise level. And also technology-wise, with this new technology, for example, in the past, we have a lot of like Hadoop or S3 or database-driven data source. And today, like over 70 or 90% of the company are using Kafka. So for example, myself, I think I heard of Kafka. I'm not sure about that, maybe 10 years ago or 12 years ago, if that exists. So at that time, it's still very sexy and modern new technology. But today, it's just the de facto standard. Everyone uses it. Yeah, this is more like the rising of streaming processing. It's not as mature as those OLTP or those standard way. It's getting better, more tools available for you, but there's a lot of different options, pros and cons. That's also part of the reason why we think it's an interesting moment to work on this interesting domain. Right? Yeah, and also like in the past, there's like Flink, Spark, or even earlier Storm. There's a different ways to doing this data processing in the real time. And the idea of streaming database or streaming, streaming warehouse. I mean, this slide, you can say this is for more like newcomer or beginner, but also that's also very important questions. Why we have to work on this in this way, right? Why you need a streaming database, not doing everything by yourself. The question is actually very similar to why we need a database at the first place, right? So yeah, we are not old enough to witness this part, but at the very beginning, there's no such thing about database. Everyone just handle the file by themselves, and it works okay, right? Works just fine. But later on, you realize, oh, I cannot process big enough files. There's so many concurrencies stuff. I need to handle update. Then someone come to this idea of like database so that you don't have to do everything by yourself. Otherwise, you can easily have some auto memory or have too many kind of reinvent the wheel over again. This somehow similar to what we are doing right now. That is those stuff like Kafka, this Flink, they provide a lot of low-level stuff. It might be okay. You don't use database concept. You don't use SQL. You have the chance to get it right, but the cost will be high. You have to write a lot of code, just like doing file system level stuff without using database. And also the other reason is far. That is, if you have limited resource, then it's unlikely you can make this optimized enough to leverage both the most recent OS features or network features. So having a database in general, it will be much easier, much safer, and much faster. And also the reason why we are talking about SQL database for streaming, not just database, because if we talk about database itself, there are so many different ways. I guess there are maybe hundreds or even thousands of different kind of database, not mentioning the actual brand. So all those KV or documentation or different favors. But SQL is still very expressive, and it's good abstraction about what you want to do instead of how you want to do it. And even there's some debate whether SQL is a real standard, because a different database vendor, even the same vendor in different versions, they may implement it in very different ways. Even the major version is the same, but sometimes you hit some issues. But again, compared to other stuff, no matter it's Python library or other framework, SQL is still considered to be a good enough abstraction layer, easy to learn, easy to express. So for example, here I list some of the like code-based database access. Maybe the first one is BerkeleyDB. It's very good, right? So people are still using BerkeleyDB, but it's very low level. And I think the other one is Aerospike, which is very high performance and high throughput database. It's more NoSQL stuff. And on the right is the DynamoDB. It is with a very good reputation, but kind of not so easy to use because you have to use their own private API. So the last part is having a SQL-based streaming database. It makes things so easy to use. Just like iPad, I'm always surprised that those young kids, even like 2 years old kid, they can just naturally swap, watch movie without any training or reading documents. It's very high bar to be such a great, easy to use product. And using SQL database can somehow make this training process or this onboarding process much shorter because they are already familiar with other kind of SQL database, but in the context of streaming. So in short, because today we are talking about running SQL on Kafka, similar to this idea is using a streaming database. And as I mentioned earlier, that is the key point is really having a very reliable system do this for you. You don't have to reinvent it well. And compared to your own solution, it will be much faster. And using SQL, you can leverage your expertise, or you can easily hire more engineers or more analysts in the market to do this streaming processing for you. You don't have to find a very expensive engineer to do that. And the running SQL on Kafka or the streaming database concept is almost equal to this one, except some extra stuff. So I will go over very quickly about what's the kind of key concept of the streaming database. So one is that you can run as SQL for sure, but traditional SQL is you run the SQL to the server do all the crazy scanning and the computation and give you the result, and that's it. But if your data is in Kafka, you always expect new data coming to Kafka. Then how to get the result for the new data? Do you have to using the traditional SQL to run this again? And what's the right frequency? Do you want to run this every 5 minutes, every 5 seconds? So this is fundamentally will be different. So there can be some kind of wasted workload or some kind of other issues if you keep running the same SQL over again. For example, you might send in too many workload to the server have to keep rescanning certain stuff. So in the new world, if you want to running SQL on Kafka, you probably want this unbounded query. You always want the system can give you the latest result without you to ask over again, what's the new result? Ideally, the system can push data to you. So this is more like bounded vs unbounded. Then if you want to get the new result, then you probably want to get a certain kind of aggregation, right? So what's the average, what's the min max, what's the P99? And then for every single aggregation, you need a more like a boundary or defining what's the logic to give you the results in a certain interval or based on the number of events. So that's the idea about the time window, either a fixed window or a size variable window, or it's based on the user transactions. There are certain, it's not really a new term, but there's a lot of discussion about what's the essential time windows or how you even can customize your window based on your own business logic. So this is different than the traditional SQL. Even in the traditional SQL, there's the idea about window, right? So it's more about provisioning, doing top K, ranking stuff, but the time window in streaming database is different. And it's also very important because you want to get to the aggregation in the right way. And the other stuff, like if you run a SQL and the SQL is always running, then anything can go wrong will go wrong. So how to handle that is either client-side disconnect or server-side reboot or some bug. And you have to making sure there's a certain mechanism to making sure your workload can be resumed when something goes wrong, or if you need more than one worker to work on the same query, and how they can share the state. So that's the idea about a checkpoint. And also, not all the data will come in time, right? With all kinds of reasons, for example, the networking issues, or maybe the device have the wrong clock. All kind of different factor can give you the result that certain data cannot arrive on time. It's not always the data you expect, which is 1 or 2 seconds ago, maybe it will be 5 minutes late. Then back to our acquisition logic, do you have to keep waiting for all the data, or you have to make a certain kind of a policy, certain late event will be either dropped or will be backfilled. So that's the idea about watermark, which is a fancy term, but the essential is give you the kind of a thresholding stuff, how long will wait for such a late event. And the Materialize, as I mentioned, it has become one of the popular mechanism in different systems. I think more and more, even I think AWS, they have a more materialized view in the Redshift in the recent event, I think. So yeah, so it's become a very popular way to define how you can run a SQL in the background continuously, then you can get to the latest result without waiting. So that's also a cool idea. Even some company name themselves as Materialize, and they are also one of the key players in this domain. Other stuff like if you want to run SQL on Kafka, then do you need to put all the data in Kafka? Like, do you want to put the recent like 1 month or 1 year data in Kafka, and how expensive it will be? Then there's other messaging bus, or for example, message broker such as Pulsar or even Kafka or Panda. They are all working on this domain to see whether we can have tiered storage, say the recent data in the regular memory / file system. Then some older data can be archived to cheaper storage such as S3. So because you want to access a lot of real-time data, or you wanted to compare the real-time data with your historical data, then we cannot assume all the data is always in Kafka. So that's the reason why many of us work on this tiered storage. And lastly, that is not everything is in the Kafka already. You still have data in file system, in database, or in different SaaS system like HubSpot or Salesforce. Then how you can making sure all the data will be consolidated in a message bus such as Kafka, then you can run SQL. You don't want to run the SQL directly on HubSpot or Salesforce. So you need a certain connector or source connector to move data into Kafka or other message bus. And also, after you run the SQL or after you run the streaming analysis, you probably want to inform other systems or downstream systems to take actions or at least visualize it, right? So this needs a certain kind of sync connectors. So the list can be go on and on. So the basic idea is simple. That is, with more data in Kafka, it will be nice if we can run SQL on Kafka. But it sounds simple, but there's also a lot of other factors you have to consider. So this is the hard part. And also, let me quickly go over the different time window. For example, this one is called time window. It's just every single purple dot represents one data, and on the y-axis, for example, there are 3 different devices, and anytime they can send some new data. But the idea of time window is give you this fixed window. Say I want to aggregate every 1 minute. That in that 1 minute, I can do kind of group by. I can do all the mean, average, or aggregation to figure out what's the value, so I can reduce the amount of raw data and have a much structured with a lower volume. So that's the idea about time window. And the hopping window is similar as this fixed window, but there's certain overlap. The reason is that if you define the time window as say for example, every 1 minute, then you only get result every 1 minute. Sometimes, in some cases, this can be too late. For example, if you are monitoring your server load, or if you are monitoring your device temperature, if you wait for the next window, maybe the device is already too hot. So what you want to do that is, I want to see what's the the temperature or the min max temperature for the recent, for example, 5 seconds or 20 seconds, and then this window can keep moving. So this can give you much more kind of in-time notification with the fixed window. And there's other kind of fixed, for example, other changes such as the session window is, the size of the window is different, depends on whether you have idle, whether you have a lot of event in the same time. If the events don't come, if considered as idle, then you can close the window. So this can be very useful if you want to understand, for example, Netflix, you want to understand like how your user watching your video, then you don't want to count those time who are idle. So there's some use case for the session window, and the idea about watermark is really to, for example, this one you have data coming, and suddenly there's a new data. Then you will set this watermark as this blue line. Then in the future, if you get 2 events which is below this watermark, you most likely will not include them in your streaming processing. You still have the chance to put them in other storage. Then you can do some kind of backfill or do some kind of batch processing, but you probably don't want to wait event which is too long. Then maybe the last one just on the watermark, then you can have the chance to include them. So that's more like the 101 session about why we think this is the either right time or a very critical moment for us to work on streaming database or run SQL on Kafka. Definitely it's not that mature as other domain, but the trend is there, and there's more and more players and more and more either customers or developers want to get real-time data in. Then maybe I will turn to Gang to share more about what kind of option you have and what's their strengths, what's their challenge, and also from our own perspective, what's the future for this domain? Yeah, Gang, please.
Okay, so yeah, let's continue. So next, I'm going to talk about some of those databases, technologies that we can use to analysis or query data on Kafka, right? We are going to talk about ksqlDB. We are going to talk about Flink and Spark. There's Trino. So probably you know Presto, but basically Trino is the same as Presto. There's like Matt had mentioned, the Materialize DB. And there's another database vendor called Rising Wave. It's actually very similar like Materialize, same technology, same concept. And of course, we are going to talk about Timeplus, which is what we are building. We have a database, stream database core engine as well. So I'm going to talk about these different technologies, do some basic demos, and then we can wrap up to compare what's the difference between these different technologies. Okay, so first thing I'm going to talk about Flink, because Flink is the de facto standard for stream processing, right? So basically you can run FlinkSQL to query data on Kafka. So in that case, the model is something like this. So you have a table, and when you create a table, you set up a connector to the Kafka, right? And that connector is actually a bidirectional. So it means you can query, the table is connected to the Kafka. You can query the data from Kafka when you run select. Also, you can insert data to Kafka by insert into that table. So it's something like when you have a table in Flink, right? It build a bidirectional connection with the Kafka. Yeah. Next, I'm going to show you some demo. So you see, I have a 3-node cluster of Kafka running here. So this is our demo Kafka data. So it simulates some. There's a shared car like a EVO, right? We talk about. So each car is actually sending data, right? Flink SQL client. So here is the Flink SQL I'm going to show. So actually, the first thing I'm going to do is create a table. You get the table has been created. Yeah, it should be continually give you data. You see, it's a little bit slow because maybe Java in Flink world, it has to create a job, submit the job. So it has some bootstrap time. So it's not that interactive, but once the job is running, it looks fine, right? So even though Flink has it's more like a developer tool. If you have a development team, you probably can handle Flink, right? But if you don't have a dedicated technical team, right? It could be hard for you to run Flink. Yeah. But still, Flink is popular. It's still the best stream processing engine and widely used, right? So if you do have knowledge and you have, I think you have a strong team, you can. Flink is a good choice if you want to search, or query data on Kafka, right? So Flink is the first one we show here. So next one, I'm going to talk about Trino. So probably if you don't know Trino, you probably know Presto, right? They're basically same, but the community was kind of break into two, product. You can, if you are interested to that story, you can search. But basically, Trino is it used to be, I think, developed by Facebook, right? It's a in-memory database engine, right? You can query data anywhere using Presto. It's an open framework. So Trino has a Kafka connector as well. So you can see the architecture or concept is quite similar like a Flink, right? But the only difference is that Flink is a stream processing engine and Trino is actually a batch, right? So when you build this connector with Trino, the idea you can do the similar stuff, but what Trino is doing is actually scan all your data in Kafka and probably put them in the memory and give you analytical result. But it's not in a streaming way. It's more like in a batching way. And another one is actually it needs some manually configuration. So first one, you put some Kafka property in your system to configure the Kafka schema. And then if you want to decode the JSON in the Kafka, you need to create some table configuration. So this one cannot be done in the SQL way. So you have to pre-configure these settings by yourself. So that's not flexible. That's how Trino is working. I've already set all this down. So I will go directly into the Trino SQL part. Right. Let's take a look how Trino works. So as I mentioned, Trino is like a batch processing. When I run the same query, I actually search all the data, and you can see we got this data. Next one, I'm going to talk about ksqlDB because if you are using Confluent or you use Confluent Cloud, it's all-in-one solution. You have ksql, you have Kafka Connect, you have schema registry. Anyway, there's a lot of stuff in that bucket, right? And ksqlDB is another one. It's tightly integrated with Kafka. So basically, it can. There's something different because in ksql concept they have table and stream. Right? That's something different. Well, I'm going to explain it a little bit. Stream is similar like the Kafka topic. It's an append only, right? It's event based. You get event 1, event 2, event 3, append only to the stream. A table is something different because when in Kafka ksqlDB, the concept is for the table, you have a key, right? For example, you have the key is a car ID, right? I have the car ID, say my speed is 100, and the same car ID even come on say 102. That means probably you update the table, right? You get a new version of the car speed based on the same key. So for each key, you only keep a latest version. Right? That's the table compared to the stream. So actually, I think Confluent has a famous slides talk about that. The two sides of the same form, table and stream. That's how the Confluent ksql make the model. So basically, you can create table and stream and you can that table stream can connect to the Kafka topic, and you can run query on the table or on the stream. I can do some quick demo on this as well. Okay, I'm going to create those stuffs using ksql. So after I create this stream, you can see it's much better than Flink. It gives you a result immediately because there's no like Flink job creation, submit job. So it's much better, right? And it looks faster as well. Right. So that's because I think Confluent make a good integration with their own product, right? So there's still a 1 minute aggregation, but you can see actually it gives you a result. It's not it doesn't close the window in 1 minute. But instead, it gives you data every time there's an event. So it's even based.
Yeah, but I think in the recent version of ksql, they have this new they call emit final. That is when the window closed, they can emit once.
Materialize is a leading streaming database in this area. So you can see the concept is a little bit different compared to the other models. So it has the source and seek, right? So that's very because in previous concept, there's no such concept of source and seek. The Materialize create this. So that means you have a Kafka source. Based on this source, you run some query, create a Materialize view, and you can query this Materialize view. And this Materialize view can link to a sink, which means that sink will write data to a Kafka topic as well. So I'm going to show something about that. So Materialize is actually I'm using the PostgreSQL client because Materialize has a PostgreSQL protocol. So basically, you can use it just like any Postgres servers. Okay. So now the source has been created. So next step, I'll create a Materialize view, doing some data binding, data extractions. And then I can run this tumble window. This is how Timeplus model this part. You have source, stream, very similar concept like a Materialize, but a little bit different when if I show you the demo. Okay, yeah, this is a Timeplus UI. It's we call it console, right? It's Joe's account. So we are now run public beta. That means it's free to use. You're just using your Google account. You can go to use it free. But I've already created a source here. You can see here the car demo. It's actually reading the topic from the car live data and insert into the this topic. So in the stream, we can see this car lab data from Kafka. Let me take a look. Yeah, it's actually working, but you can see that it's same concept. That source is connected to the topic, and we are actually reading data from the topic. You get all the real-time data here.
So for this particular one, we don't set any time window, whatever. So this is called global aggregation. That is, from the moment you start a query to forever, as long as the query is not complete, we always calculate what's the max. So in this case, we do this calculation.
Of course, we can run the other aggregation like a tumble window. So we just tumble from this car, say I want to do the 5-second aggregation, group by window start.
And the syntax is similar to other ones, a little bit more easier. So that now you have to write interval.
And
some streaming companies deploy databases like I forget the names, but like some companies say deploy Flink, right? You mentioned that earlier today. Is what you are showing here, is this a streaming engine that you built yourself as like the company has built, or are you deploying one of the other tools that you showed us? Like, is this
yeah,
one of the other tools we already saw?
Right, sure. We build the engine is built by ourselves. We actually build we are different technology. I will mention that later.
Okay.
But we are using C++ to build the engine. It's a little bit different. Of course, we can actually export the results like downstream. We can send data to another Timeplus or send to Slack, email, or any other. We are still, that means we can send data to downstream as well. So in the UI, we can do the settings. So yeah, that's the demo part. So a quick summary here about the different technology we are showing today. So you can see this table, right? So we show you Flink, ksql, Trino, Materialize. Rising Wave I didn't show, but it's basically the same as Materialize and Timeplus, right? So all of them most likely stream processing. Trino is batch. Materialize and Rising Wave has streaming processing under the hood, but you can still consume the data like a database, right? You can still run the batch query. And Timeplus is similar. We support both batch and streaming, but streaming is mainly what we are building. So consumption, like most of the streaming processing, when you consume data, you actually the server will push the data. You don't have to pull the data. But Trino is batch, so it's full based. The programming language like Flink, ksql, Trino, they're Java based. Materialize Rising Wave is Rust based. And Timeplus is we build it using C++. So that's the under hood engine. So for the stream processing, you for sure get this time window. But some other doesn't, like I mentioned, actually Rising Wave has this time window, but Materialize only you have to calculate the window by yourself. It doesn't have embedded function for time window. For the storage, you can see Flink doesn't have storage. It's a pure stream processing engine, so it doesn't store data by itself. But there's a community plan to support table engine that they're doing that, right? ksql using Kafka as storage, so it stores everything in Kafka internally, right? Of course, they have their checkpoint or using RocksDB. Trino is an in-memory engine, so Trino doesn't store data as well. Materialize has its cloud, Rising Wave has this cloud local storage, but they're moving very fast. Previously, Materialize is also a pure in-memory engine, but they're building their storage now. Timeplus has a cloud storage and local storage as well. Actually, Timeplus has a historical engine. That means we can actually run as a batch or lab database in the batch mode. So Timeplus is actually dual mode for both streaming processing and like a batch processing at all lab. And the license is quite different. Like Flink is the open source Apache. ksql is the CCL. They're all Confluent community license. Trino is Apache, and Rising Wave is Apache. The Materialize is BSL. So that means these two licenses, like a ksqlDB and Materialize DB, is not a pure open source because their license is not user friendly. Because Timeplus we are pretty new. We're still building everything, but we do have a plan to open source our core. But we are at very early stage. We think even the open source our code now, probably nobody will be using it. So we probably will wait a good timing to open source our core. So, but now if you want to try Timeplus, it's free to use because we are running public beta. Okay, so this is the data architecture. This is from the K60Z. There's a big data landscape. So, but there's something related to the streaming data, right? Like even streaming, you have Kafka, Kinesis, Pulsar. And for the real-time analytic, you have previously you have ClickHouse, Pinode, or Rockset, right? And also the stream processing engine like Databricks means I think probably that's the Spark, right? Confluence has ksql Link and some Materialize DB, right? This is stream processing. So and Timeplus we actually here by real-time analytics. Right? So that's something we are building now. Yeah, this is the overall architecture, high level stuff of what Timeplus is doing. So we have connectors to the upstreams, the connector to the downstreams. We have an internal storage for the streaming data and historical data. So we build our own data format so that, like I mentioned, if you want to analysis data on streaming on Kafka, it's not easy because it's an append learning log. It's not a you cannot build index. You cannot skip something. You cannot filter out a column like a column database. So that's hard. So that's why we build our own data format, and we work closely streaming first store, and also we have a historical store, so you can run query smoothly between streaming mode and also the historical mode. So we have our own SQL engine. We have a streaming processing engine. So we leverage vectorized computing to boost the query performance. Also, you can see that we actually has an all-in-one platform. So we have real-time dashboard. We have alert function built in, right? So that means I didn't show that today, but we do provide visualizations. That means we have a real-time chart and real-time dashboard. So that means we are not just a SQL engine. We actually it's an analytic platform. You can do the and streaming analytics on Timeplus. So this is some showcase we have building. We do have a showcase where we analysis the GitHub data, right? I'm not going to talk about those, but we do have built some fleet management solutions, because one of our customers is running a large number of fleet, the trucks, right? So the security is their concern, and this real-time security. So once there's some truck is over speed, or the driver is driving too much without rest, so we can send an alert, say, oh, there's some car is over speed, or some driver didn't have rest in the past time. So we notify them in real time. So they think this some solution they really love. So this is something built using Timeplus technologies. Okay, so yeah, that's probably Joe. You want to make some wrap up?
So we can leave more time for the Q&A session. But just to wrap up, that is, I hope you learned something. Sorry, this entire session can be long, but the idea that is, compared to 5 years ago, the customer really have a much higher expectation to see what's happening right now. As enterprise, you want to get to the report earlier, you want to take real-time actions. Ideally, even no human being in action, everything can automated, that'd be great. And you don't want to spend too much time reinvent the wheel, manage infra. So we do have a much better choices compared to 5 years ago, like the rising of streaming or streaming database. And there's a lot of new semantics or best practice being invented. And we are glad to work with the vendors to make this easier for you. And there's so many different use cases, the customer 360 or the fintech. There are so many use cases, no matter external or internally. So I'm glad you guys joined the session. Hopefully you can try to understand what's going on in your Kafka, maybe using SQL, maybe using Timeplus, maybe use other tools, but try to do more with your real-time data. And that's something that will be very interesting ahead. Yeah. So maybe with that, we can take questions or
any
doing freestyle check. Yeah.